Okay, so we had T and S distributions on Rn. At least one of them with compact support. Then we define T star S belongs to D prime of Rn, which is characterized by the following conditions. T star S acting on phi is T star S star phi chesh evaluated at 0, and T star S star phi is equal to T star S star phi, and both these for all phi in D of R. So, either of these will verify, will characterize T star S. It is a unique one. So, now we want to show that this convolution has all the properties with functions enjoy, and therefore, we have the following theorem. So, T1 and T2 distributions in Rn on Rn, at least one with compact support, then T1 star T2 equals T2 star T1. So, you have commutativity. So, this is the first part. So, then okay. The second one, T1 and T2 as above, then support of T1 star T2 is contained in support of T1 plus support of T2. Three, T1, T2, T3 in D prime Rn, at least two of them with compact support, then T1 star T2 star T3 equals T1 star T2 star T3. Let us take any two of them. Let us say T2, T3 have compact support, then by 2 T2 star T3 will also have compact support because it is contained set of sum of two compact sets. So, it is also compact. Then I can convolve it with T1. Now, if T1 star T2 is T2 has compact support, and therefore, this distribution, and then T3 has compact support. So, I can do the convolution. So, you can check with any of them, any two have compact support, then this is all, both sides are always defined. For T1 and T2 as in 1, so at least one of them with compact support, alpha any multi-index, and then d alpha of T1 star T2 equals d alpha T1 star T2 equals T1 star d alpha T2. So, you can push the derivative wherever you like. Okay. So, now let us give a proof of these properties which mirror the properties of convolution of functions. So, first one. So, let phi 1 and phi 2 in D of Rn arbitrary. Okay. So, let us take T1 star T2 star phi 1 star phi 2. So, this again is infinity function with compact support. So therefore, we know you have two distributions, one of them compact support and a C infinity function with compact support. So we have proved this theorem T1 star, T2 star, phi 1 star phi 2. Now that is equal to T1 star, T2 star phi 1 star phi 2. Again we have shown this when you have two with compact support and one is a distribution. So you have this. Okay, so you have a distribution and two functions with compact support. So once again I am using this theorem. Now this is equal to T1 star phi 2 star T2 star phi 1. I am just using the commutativity of the convolution of functions. Now so now I want, suppose T2 has compact support, then this has T2 star phi 1 will also have compact support, we have seen that, and this has compact support, so we can use the associativity law. If T1 has compact support, then you have again phi 2 has compact support and this is the C infinity function. Once again we have the second theorem which we proved, that can be used, and therefore this can be written as T1 star phi 2 star T2 star phi 1, okay, using the two preceding theorems. Okay. Similarly, T2 star T1 star phi 1 star phi 2, this is equal to T2 star T1 phi 2 star phi 1, and now going by what went, you have first with the second and second with the first. So this is T2 star phi 1 star T1 star phi 2, and this is equal to phi 2, sorry, and this is equal to T1 star phi 2 by the commutativity of functions star T2 star phi 1. So these two are equal. So we have T1 star T2 star phi 1 star phi 2 equals T1 star T2 star phi 2 T2 star T1 star phi 1 star phi 2. And now this is T1 star T2 star phi 1 star phi 2, again by the associative law which we have proved, T2 star T1 star phi 1 star phi 2. But then by the fourth part of the first one, that is if T star phi equal to 0 for all phi in D of Rn, then T equals 0. So this is a very important thing. So I can cancel this, and so you get T1 star T2 star phi 1 equals T2 star T1 star phi 1. This is for all phi 1 phi 2 and this is for all phi 1. Again this is true for all phi 1, and therefore I can once more cancel it, and so I will get T1 star T2 equals T2 star T1. Okay. So this proves the first part. So the second part, so by 1, without loss of generality, assume T2 has compact support. So we have T1 and T2. So if one of them has compact support, if T1 has compact support, then T1 star T2 is T2 star T1. So the second one you can say always has compact support. Now if you take any phi in D of Rn, then you have T1 star T2 acting on phi equals T1 star T2 star phi chesh evaluated at 0. And what is that equal to? So you have this is a C infinity function with compact support this distribution, and you are evaluating at 0. So, this is nothing but T1 at T2 star phi chesh. Okay, that is I am just using the definition of the function, the convolution of this distribution and a C infinity function with compact support. But what is support of T2 star phi chesh? This is contained in support of T2 plus the support of phi chesh, which is minus support of phi. So, if support of T1 intersection support of T2 minus support of phi is empty, then this will mean that T1 star T2 acting on phi will be equal to 0. So, that means this will be 0 because this has a support which is the minus of this one. So, we have to take the minus of that because we have a chesh. So, support of phi minus support of T2, because that is the minus of this, and therefore, which is the support of T2 star phi chesh, and therefore, if these two are disjoint, then this will be 0. So, this implies that 2 should not be disjoint, that means implies support of T1 star T2. So, T1 star T2 will vanish on the complement of, so this implies T1 star T2 vanishes on the complement of support T1 plus support T2. From this it follows, and therefore, this means support of T1 star T2 is contained in support T1 plus support of T2. Okay, so that is the second part. So, now let us take the third one. So, if T1, T2, T3, two of them have compact support. I already checked that you can define any of those triple operations. So, let us assume T3 has compact support. At least two of them will have. So, let us assume T3 has compact support. So, T1 star, let phi belong to D of Rn arbitrarily. Okay, so T1 star T2 star T3 star phi equals T1 star T2 star T3 star phi. Again, I am using the fact that you have two distributions and the star. So, it is characterized, the convolution is characterized this way, okay, and that is equal to T1 star. Again, in the middle I am using once more that property T2 star T3 star phi. And then T1 star T2 star T3 star phi. Now, the last one is possible because T3 star phi is a C infinity function with compact support, because phi and T3 are both having compact support. Okay, now this is equal to T1 star T2 star T3 star phi. Again, T3 star phi has compact support. So, this is equal to T1 star, this is where I am using it, T2 star T3 star phi. So, this has compact support, and therefore, I can use the characterization. So, these two are equal. So, they are equal for all phi. So, this implies true for all phi. So, T1 star by the cancellation theorem, you have this equal to T1 star T2 star T3. So, what happens if T3 does not have compact support? Now, we use the commutativity. If T3 does not have compact support, then T1 and T2 have compact support. So, we get T1 star T2 star T3 is equal to T1 star T3 star T2 by the commutativity. This is equal to T3 star T2 star T1. Now, T1 has compact support, and therefore, by the first part of this section, so you have this is T3 star T2 star T1, which is equal to T2 star T1 star T3, which is equal to T1 star T2 star T3, and that proves the whole thing. Okay. So, now 4. So, phi in D of Rn and alpha any multi-index. Okay. So, then again we will use the cancellation d alpha star T1 star T2 star phi. This can be written as T1 star T2 star d alpha phi, because we have seen that we can push the derivative to a function if necessary, and that is equal to T2 star T1 star d alpha phi again by the commutativity. Now, I will use this is here is a C infinity function with compact support. So, T1 star T2 star d alpha phi, and this will be T2 star T1 star d alpha phi, and that is equal to T1 star. Now, inside this I can write this as d alpha T2 star phi. We have already seen that is equal to T2 star. Similarly, I will write d alpha T1 star phi. Now, you have two distributions and phi which is C infinity with compact support. So, this is T1 star d alpha T2 star phi, which is equal to T2 star d alpha T1 star phi, and which is of course equal to d alpha T1 star T2 star phi by the this, and therefore, you can now apply the cancellation law. Phi is for any arbitrary phi, this is true. So, d alpha T1 star T2 equals T1 star d alpha T2 equals T2 d alpha T1 star T2. Okay. So, this proves that result also. Okay. So, now as an example, and also it's important, the Dirac distribution plays a particularly important state, has a special status with respect to convolution. So, theorem T in D prime of R n delta equals Dirac distribution concentrated at 0, then T equals delta star T equals T star delta. So, if you, it is like acting like the identity element in this binary operation. Okay, delta is like the identity. If alpha any multi-index, then d alpha T equals d alpha delta star T. Remember, delta has support singleton at the origin, so do all its derivatives, and therefore it is a distribution with compact support. Therefore, you can convolve it with any other distribution, there is no problem. Okay, so proof. Let phi belong to D of R. Then delta star phi at x, this is equal to delta of tau x of phi chesh. This is how we defined it, and that is equal to tau x of phi chesh evaluated at 0, that is the delta thing, and that is equal to phi chesh evaluated at minus x, which is phi of x. So, delta star phi equal to delta equal to phi. So, if you take t star delta star phi for any phi, this is t star delta star phi, which is equal to t star phi, and so by the cancellation law I can again cancel this, and therefore you get t star delta equal to t, and this of course equal to delta star t, there is no problem. Now, if you take d alpha of t, that is equal to d alpha t star delta, and you know now you can put it as t star d alpha delta, and therefore you equals d alpha delta star t. Okay, so this proves this theorem. Okay, so if you have, so remark, if you have T1 to Tn in d prime Rn, then by pairwise convolution in any order, since we have commutativity and associativity, okay, we can define T1 star Tn, provided, this is very important, at least n minus 1 of them have compact support. So, this without this compact support you cannot have the associative law, and therefore you cannot in an unambiguous way define the convolution in all this. So, let us give an example. So, let us take 3 distributions. So, T1 is the constant distribution, that means what? T1 phi equals integral phi, okay. Then T2 is the Heaviside function. So, T2 phi, sorry, T2 is the derivative of the Dirac. So, T2 of phi is equal to minus phi dash 0, and T3 is the Heaviside distribution, Heaviside function. T3 of phi is integral h phi. Okay, so these are the 3 distributions we have. So, let us take delta prime star h. This is equal to delta star h prime, but h prime is delta. We have seen this, the distribution derivative of the Heaviside is the Dirac, and so that gives you delta. Now, 1 star delta prime is 1 prime star delta. So, you have a constant function distribution derivative is 0, that is 0 star delta, and that will give you just 0. So, let us take 1 star delta prime star h, this is equal to 1 star delta, which is equal to 1. On the other hand, you have 1 star delta prime star h will give you 0 star h, which is 0. So, these two are not equal, so you do not have the associative law. Okay. So, therefore, it is important, and why is it so? This is not of compact support. So, support not compact, in fact, it is the entire real line. This is support compact, and this support not compact. It is a negative positive real axis. Okay. So, therefore, you have two of them with non-compact supports, and therefore, you cannot do this. So, this so much about the convolution of distributions. Now, we will look at some applications. Okay.